Okay, so the first one here, it says determine whether the conjecture is true or false. That conjecture word might throw you off. A conjecture, this was, I know, a couple chapters ago, is an educated guess based on a pattern. Educated guess based on a pattern. So for example, like if you had a pattern like 2, 4, 6, and then they wanted you to make a conjecture about the next term, you could guess that it's going to be 8 because they're counting by 2s. That makes sense. So here it says determine whether this conjecture is true or false. It says if n is a real number, then n squared is greater than or equal to n. Explain if false, provide a counterexample. So it makes sense that n squared would be greater than n, like 2 squared 4 would be greater than or equal to 2 kind of thing. However, it's not always true. And a counterexample, so a counterexample would prove it false. Counterexample would be, okay, what if n is a fraction, like 1/2? 1/2 squared would not be greater or equal than 1/2 because like 1/2 times 1/2 would be 1/4, and 1/4 is not greater than or equal to 1/2. So this is false because we can think of a counterexample like this. And remember, a counterexample like proves the statement false. It's an example that shows that it's not always true. Okay, so the next one requires us to review something from before. So the next one, it says write a conditional statement and a converse, and then write a biconditional statement if possible. Okay, so just kind of reviewing here, a conditional statement was P then Q, and it's often in this format, if P then Q. P is the hypothesis and Q is the conclusion, and it's in this format. And then once you have a conditional statement, you can come up with all of these, the converse, inverse, contrapositive, and you're just like changing the order of the statements, or the squiggly line means not. So not P, then not Q, and so on. So for this one, it says it wants us to write a conditional in converse. It actually already gives us the conditional. So conditional is P, then Q. And it says if two angles share a common side, then the angles are adjacent. So this is P, and then this is Q. The second part's Q. And then converse is Q, then P. So we're just going to change the order of the statements. If the angles are adjacent, and I'm going to abbreviate, then two angles share a common side. So we just change the order of the statements. And sometimes changing the order will make it so it's like a false statement. But other times it stays true. And in this case, it does stay true. If the angles are adjacent, then they share a common side. When the conditional and converse are both true, that's when you can make a biconditional statement. And a biconditional statement has the words if and only if in the statement. And we just take these two statements and we put it in this format. Two angles are adjacent if and only if they share a common side. So if both true, a biconditional can be made. Okay, number 13 actually isn't part of our standards. It's part of the textbook, but it's not part of our standards. So we're actually going to skip over 13. You don't need to rate that. And then number 14, it says which of the following are used when writing proofs. So a proof is like when you do like the statements and reasons. Statements and reasons, and then you like have your statements and reasons and you fill out the 2-column proof. So what can be used in proofs? You can use definitions, postulates, theorems, undefined terms like points, line, plane. What can't be used is conjectures. So a conjecture is an educated guess, and it wouldn't make sense to use an educated guess to prove something, so you can't use conjectures. Okay, then the next one over here. We're going to need to draw a picture. It said that point B is the midpoint of AC, so I'm going to draw that. Point B is the midpoint of AC. So that means that this length is the same length as this. And it also says point C is the midpoint of AD. So I'm going to draw a larger segment, call this D, and now C is the midpoint of this whole thing. So like CD and AC are the same length. So this here is the same length as this. Okay, so it says that CD right here is 12 units. So this would be 12. What is the length of AB? Well, if this whole thing is 12, then this whole part is 12, and then it's half and half here, so this would be 6 and 6. So AB equals 6 units. Okay, the next one, it says x, y, and z are collinear, meaning they fall in a straight line. Y is a midpoint of xz. Find the value of b right here. Well, if y is a midpoint, then these two would be equal, and we can set them equal to find b. So 2b plus 7 equals 3b minus 4. And we can subtract 2b from both sides. We get 7 equals b minus 4 plus 4 to both sides, and b equals 11. It doesn't ask for the length of anything, just the value of b, so we can stop there. Okay, and then this one, in the figure below, find the value of x and the measure of ABD, so this angle right here, and then also the measure of DBC, which is this angle right here. So we're first going to find the value of x. We see this little square here, meaning that this over here is 90 degrees as well. So these two angles added together equal 90. So that's how we're going to set it up. 2x plus 8 plus x minus 5 equals 90 degrees. And combine like terms. And x equals 29. So that was one of the answers it asked for. It asked for the value of x. It also asked for the measure of both of the angles. So first of all, measure of ABD is 2x plus 8, so that would be 2 times 29 plus 8, which is 58 plus 8, which is 66 degrees. And then this one right here, the measure of DBC is x minus 5, so that would be 29 minus 5, which would be 24 degrees.